Hey everybody, welcome to Problem of the Week number 7. Wow, can you believe it? 7 of these. Thanks again to all those students who always finish their problem of the week. And although we don't always get it correct, you are learning so much along the way, and your knowledge of a variety of different mathematical skills comes out in every question. So thank you so much for your continued hard work. 2 thumbs up for you. All right, today we are dealing with Bridget's leaky boat. All right, so there's a bunch of things that happen, but I always like to pull out some key information. So here's the key information for this question. 144 liters is all this poor little boat can take, meaning that once this boat fills up with 144 liters, it will sink. We don't want Bridget to sink. So question A says, if Bridget does not bail out any water, how much water would there be in the boat after 1 minute? And what about after 30 minutes? So we already know that in the question they say that in 1 minute, the boat will fill with 3 liters of water. So if we use that and we calculate for 30 minutes, all we're going to do is multiply 3 by 30. All right, so 3 times 30, all right, 3 liters per minute and a 30-minute span of time, and that would equal 90. So in 30 minutes, there would be 90 liters of water. All right. And that's without Bridget doing anything. That's just if we let the water come in. And it says in part B, but of course, Bridget does bail water out of the boat. Using her pail, she removes 1.4 liters. So again, we pull out important information. So Bridget's removing 1.4 liters of water every minute. And the question is asking how many liters of water remain at the bottom of the boat after 1 minute. Okay, well, this is some simple subtraction. So in 1 minute, we know that there are 3 liters. And if she's bailing out 1.4, we're just going to subtract that number from 3. So 3 minus 1.4 liters leaves us with 1.6 liters remaining. Okay? So again, in 1 minute, 3 liters leak into the boat. Bridget scoops out 1.4 liters each minute, which leaves 1.6 liters still in the boat after that 1 minute. All right, so the second part of that question is how much water would be remaining after 30 minutes? Okay, so you could do this a couple ways. I chose to use multiplication. So I knew that my span of time was 30 minutes. All right. And I know that she's removing 1.4 liters every minute. So if I times it by 30, that's going to tell me how much she's taken out in 30 minutes. So if I do 30 times 1.4, I am left with 42. So in 30 minutes, Bridget is removing 42 liters of water. Okay. So that's how much she's taking out, and we still have to figure out how much still remains in the boat. So again, we use our subtraction skills. So we know from before that in a 30-minute time, there'd be 90 liters of water coming in. We now know that in a 30-minute span of time, she can remove 42 liters. So if we take 90 liters minus 42 liters we are left with 48 liters still in the boat after 30 minutes. Okay, so now we can start using that information to fill in the chart, and the chart is part C. I did 1, 2, 3 instead of ABC. Sorry about that, but the chart's still the same. So we're going to start using all this information that we're collecting right now to fill in this chart. So let's fill in what we know already. So we know in a half an hour, so 0.5 means half of 1 hour, how many liters were still left in the boat? Well, that's what we just calculated. So in a half an hour, there would still be 48 liters left in the boat. And in that amount of time, she's traveled 1 kilometer. Now, this gets to the next part of the question where some important things come into factor. We know that the boat will sink if it has 144 liters of water. And basically what they're asking us is, how far did she travel from the dock to where she hit that rock to the point where she sprung a leak and then started paddling back or rowing back? How far did she travel? Okay, so we're going to use the water along with time and distance to calculate that. So, a half hour, there's still 48 liters remaining in her boat, and she's traveled 1 kilometer, okay? After 1 hour, all right, we're just going to add another 48 to what we have, and that equals 96, all right? The reason we add another 48 is because we're just using the information from the first line in our table, and knowing that every half an hour, there's 48 liters of water coming into the boat. So we just add another 48. So after 1 hour, there's now 96 liters of water in the boat. And she's traveled now 2 kilometers. Okay, so we're still not at 144. And that's kind of the magic number. That's when her boat will sink. And we know her boat's going to sink right off the edge of the dock. So that basically tells us the whole distance she's traveling. All right, so then we go down to the next span of time, and we're moving in increments of a half an hour. So now we're going to go to 1.5, all right? And we're just going to follow the pattern in the table. So every time we've moved so far, we started with 48, then we added another 48. And all I'm going to do now is add another 48. And you'll see that I arrive at 144 liters. And she's now traveled 3 kilometers. All right. So to answer the question for part C, when we complete this table, is she will have traveled 3 kilometers from the rock that she hit in the middle of the lake that she's in. So from that rock to her dock. From the rock to the dock, okay? So as long as your numbers match what I have here in my table, you've solved that portion of the question. So moving on, they kind of change things up a little bit for the challenge part. So number 3 is the challenge. And there's a lot of things going on here, so please bear with me, and hopefully I can explain it in a way that is not confusing. So we have to pay attention to what has changed. And the biggest change in this chart here, you can see right away, is the time and its relationship to distance. Because in this scenario, they're saying that Bridget's bailing out more water, which causes her to slow down because she can't paddle as much. So in a half an hour now, she's only traveling half a kilometer. Whereas in the last scenario, in a half an hour, she was going double that. She was going 1 kilometer. Okay, so our distance is cut down, which is going to affect everything else. So I'm just looking at my notes here. All right. Okay, so the next important piece of information that is in the question is that she traveled an extra 1 kilometer than she did in the previous question. So that is a huge clue. And like in a lot of these problems, we kind of have to work backwards sometimes. So I take the information I'm given, and in the challenge part, this was a huge clue along with the shortened distance that she's traveling. So if she traveled an extra 1 kilometer, I tack that on to what I figured out in the previous table. All right, so last time in that scenario, she traveled 3 kilometers to get from the rock she hit to the dock, from the rock to the dock. And now, because they're adding an extra kilometer, we can increase our numbers in that table. So just kind of bear with me as I jot things down here. Because I'm moving in half a kilometer increments, I'm going to keep my table moving up in half increments of half. Okay, so my next one would be 1, and then 1.5, and then 2, and then 2.5, and then 3, 3.5, and then 4. So 4 is our final distance. So now here's what I did. Well, actually, let me fill in the time too, just so that that matches up. You're going to find that my time matches up exactly with what I have in my distance. 2.5, 3, 3.5, and then 4. All right, and now what they want to know is, because she's paddling more, or sorry, now she's paddling less, but has a longer distance to travel, they want to know how much water she's bailing out before she hits that magic number of 144. And I know she makes it to the dock, so I can fill in that portion of my table here, because at the 4 kilometer mark, she's going to get to 144. So basically what I have to do is divide into increments. So there are 8 time increments, and I know the total amount of water is 144. So what I do is divide 144 by 8, because that's going to tell me how much she can bail out at each one of those 8 time increments, so that by the time she reaches the dock at 4 kilometers or 144 liters, we'll kind of have met all the parameters in the question. All right, so we know 90 liters are coming in every half hour, and we want to see how much has to get bailed out. So we also know that because we divided 144 by 8, we get an answer of 18. So that means only 18 liters can remain in the boat at each time increment, because 18 plus 18 plus 18 plus 18 plus 18 plus 18, 8 times is going to equal 144. Okay, so now all we do is kind of what we've been doing before, is use some subtraction. So we're going to go 90 minus 18, and we're going to get 72. So that means every half an hour, because she's bailing so much and paddling a lot less, she has to remove 72 liters of water. Okay. And then leaves us with 18 still in the boat. And then we would just add 18 the whole way along here. So 18 plus 18 here. This at the second interval, there would be 36 liters left in the boat, and then 54 liters left in the boat. 72, 90, 108, 126, and 144. Okay, well, we haven't fully answered the question, and again, I know this is a lot of stuff to digest here. There's a lot going on. I hope you're kind of following along. So the last thing we have to do, now that I know all my information, okay, so I know that there were 8 increments of time, still 144 liters by the time she gets to the dock, and we've also calculated now that 72 liters have to be bailed out every half a kilometer or every half an hour. But now they want to know how much has to be bailed out every minute. So we know that she's bailing out 18 liters in 30 minutes. So then we just use the numbers we already know. So 30 minutes divided by 18 liters, we are left with a number of 2.4. So for every 1 minute, Bridget is bailing out 2.4 liters of water. Wow. That was a lot of work and a lot of thinking. I hope you did okay with that. The first couple were pretty straightforward. This last one here, the challenge, that's why they call it a challenge question, my friends. It was pretty tricky. So I hope you followed along with what I was showing you. And thanks again for trying these questions. You guys are awesome. I look forward to your answers again for next week. And thanks again for trying out the problem of the week. Take care, everybody. Bye-bye.